Okay, I'm David Dailey from Slippery Rock University. We'll be hosting the conference next year, so I hope you can find your way to Pittsburgh. I'm going to be talking about something we call tansy, the word tansy having a relationship to the word tangent, as in tangents to circles. And some years ago, I sort of got involved in the standards process with HTML5 and SVG, and I discovered it was a rather strange world with lots of specialized jargon that the people within the standards world used to talk to one another. And I had lots of ideas of things I wanted to do on the web, and I'd present my ideas and they'd say, but what is the use case? And the term use case seemed like a barrier to me. Ultimately, I kind of converged on the notion that what they meant by that was, why would you ever want to do that? And they used the word use case to sort of restrict the dialogue to include only those people who were already on the inside of the standards organizations. But, so why do I want to break the rectilinear mold? Well, the web uses the box model, the CSS box model. Everything done on the web right now is done inside rectangles. But the history of human communication is not limited to rectangles. Historically, yeah, there are some rectangles there, but you'll notice that the textual elements do not flow into rectangles. And furthermore, the distinction between textual and graphic is not always clear. Sometimes you have graphics within text. Sometimes you have text within graphics. Sometimes the text flows around complex shapes. It was with the advent of the printing press that we first decided that the rectangle was the proper metaphor for presenting our ideas. Why? Well, because it was simply easier to place text inside rectangles for purposes of printing. That was a mistake. And it's a mistake that stayed with us for 500 years. And there have been several mistakes in the history of human communication, probably the invention of speech being the first. I think gesture is probably more succinct a way of communicating ideas than this linear strand of phonemes stuck in time. But some of these examples demonstrate that human communication through its history has not always been rectangular. Oh, isn't that funny? Yes. This here? This one? That one. And what do I do? Oh. I don't mind flashing yellow, but prior to the printing press, there were these things called block books. And you can see that the graphic and the text sort of coexisted happily. In fact, if you look at the early history of books, most books contained more graphic than text. And the text was sort of flowed in around the graphics to help explain the ideas. But by the time the printing press came along, graphics were stuck in as little tiny illustrations to illustrate the text. Sort of turned the meaning upside down. It made the text paramount and the graphic secondary. So in terms of use cases, there are lots of use cases for why meaningful elements, and by meaningful elements I don't mean just text, because there are lots of icons that have implicit meaning within a culture. So these are just some of the examples that I was able to sort of think of. We have the illuminated manuscripts. This is the Book of Kells. That was a pretty interesting medieval manuscript. And you'll notice that meaningful elements flow in and around the text. Another example from the Book of Kells. Here's a more modern example. I saw this in the cathedral in Bath a couple of years ago. Somebody working in the manner of the Book of Kells. There's sort of an interesting example where the graphics flow into letters that then illustrate points. Sort of a nice font. I'd like to get that font installed on my computer. Over here we have a pretty interesting font. Skeletons doing things. Over here we have a more modern instantiation of the same thing. An alphabet made of people doing yoga. Back up and do this sequentially. There are lots of examples that one can find if you Google shape poems. Lots of times the meaning of the text and the shape of the text mirror one another in interesting ways. There are also these little things called typographic puns, where the meaning of a graphic within, or the placement of the letters, or the shape of the letters somehow conveys something of the meaning of what's being said. Oh, yeah, I wanted to show that one. There are these things called callograms, in which the text is shaped into a form where the shape and the text share a meaning. It'd be awfully nice to be able to do this sort of thing using SVG. Again, the notion that text doesn't always flow into rectangles. And the things that flow into non-rectilinear shapes are sometimes not always textual, but they are meaningful. Of course, we have stained glass as a good example of meaningful elements placed in non-rectilinear geometry. This particular thing is, if you happen to be in London, go down near the Bank District, and there's an old church from the Wren era that's pretty darn cool. Lots of examples of currency in which meaningful elements are arranged in a geometry that is somehow itself meaningful. There's an 18th century Russian book with a cartoon in it. Cartoons are a clear example where the shape needs to conform to the geometry of the meaning. In this case, the shape of the bubble that contains the text is not necessarily meaningful, but it's secondary to the illustration in a sense. The late 1960s and early 70s were a great period for experimentation with fun font tricks. This was not done using SVG. But you can see that pop culture has embraced these kinds of non-rectilinear models of thinking for some time. There are also these things called mind maps, in which there's an attempt to show how thoughts interrelate to one another using some kind of spatial metaphor. Here's an experiment with thought mapping that I did in the 1970s. And then, of course, whoops, that link isn't working well. We have maps. This is an example of a Mappi Mundi. The geometry of this is kind of interesting because proximity was more semantic than geographic. In this particular case, heaven is at the top, Jerusalem is in the center. I think England is over here, France is over here. I don't remember exactly where all the things are, but it's a rather severe departure from our conception currently of how maps work. This is just a detail of that, showing once again that there are semantic elements like labels and symbols for churches and symbols for gardens and text that are all flowing into interesting shapes. One might wonder, why can't we do this on the web right now? And of course, lots of examples of art from many cultures. There's a good one. The Dada folks from Zurich were quite fond of these kind of typographic displays. And then you have Cubism, in which the elements have a semantics of sorts, but the flow is, again, non-rectilinear. So those are some use cases. Many people, including Ted Nelson, who invented the concept of the hypertext, have argued that the rectangle has limited our expressive power. Okay, now changing directions a little bit. A couple of years ago, 2009, I think, maybe 2010, we were in Paris for the graphical web. And I was I was struck by the strange geometry of the streets of Paris. Turns out that there's a history to why the streets are drawn the way they are in Paris, and it had to do with, among other things, quashing revolutions. Every so often, France would have a revolution, and the leaders of the time would have their heads publicly removed from their body. And future leaders of France decided that that was an unfortunate future that they wanted to avoid. And one way to avoid that was to get rid of the medieval architecture of the streets. The streets of Paris had medieval plans, sort of like in Winchester. The plan of the streets is sort of a Voronoi diagram. Well, Napoleon III brought in a planner, a city planner. I guess Pope Sixtus V had also brought in a city planner to redesign Rome. But Baron Haussmann, I guess it's pronounced, was commissioned by Napoleon III to redesign Paris to make it easier to get between the key points and to make it harder for the peasants to erect barricades to prevent the police from taking appropriate actions should there be a revolution. So I was struck by that, and I also attended a workshop on how to design fonts. And one of the things that struck me about the software that people use to design fonts was that the control lines that were tangent to the Bezier curves that described the font were always based on a rectilinear grid. I thought, wow, why do you need a rectilinear grid to describe the key points of your font? And why have we designed software tools that encourage that kind of rectilinear thinking? So there you have medieval Paris on one side, looking like a Voronoi diagram. and modern Paris on the right side, looking like a bunch of lines sort of intersecting one another at interesting angles. And what's flowed into these is semantics, right? Human lives, buildings, gardens, palaces, toilets, all the good things. So I was thinking about, okay, how can we design a tool that allows people to create web pages that would not flow into rectangles, that would not suffer from the limitations of the box model? Let me show one other link here. There's an area that has not yet been invented, but it should be invented. I would call it web combinatorics, and it has to do with the issue of how do you enumerate possible web structures. So for example, those two figures on the left are equivalent topologically because we've divided one rectangle into two rectangles. There's only one way to divide one rectangle into two. There are two different ways to divide a rectangle into three rectangles. That way, where you have the two lines that are dividing, not intersecting one another, and the other one where you've divided it that way. But in order to make this a combinatorial problem, you have to make certain topological restrictions of your definition such that the size of the rectangles is irrelevant. What matters is how they connect to one another. So it'd be an interesting exercise to figure out how to enumerate all the possible HTML tables or CSS layouts that could be generated by subdividing rectangles into subrectangles. Here we have the classic Voronoi diagram. And over here we have another kind of a geometric thing called a line arrangement. And there are interesting mathematical problems associated with line arrangements. How many different ways can you draw a bunch of lines in the plane? It turns out that the problem is really difficult. And there are lots of unsolved mathematical problems associated with the issue of enumerating line arrangements. So it's nice to have a little bit of backdrop that's sort of fun to think about. Let me see. I guess this is the link. There's an illustration I'm not finding. But I happen to realize that if you have, well, let's do it with the tool. Let me just illustrate how this sort of works. Suppose I have a circle. There's a circle. I can move it around. I can resize the thing. Suppose I have a second circle. If there are two circles in the plane, they automatically define four tangent lines, two of which cross through the middle and two of which cross somewhere else. How many of you learned in high school geometry how to construct given two circles, how do you find the tangent lines between those two circles? You learned that? I didn't learn that. In fact, I had to go looking for how to do it. And I found that it was probably known by Archimedes, but probably forgotten sometime after Archimedes. It resurfaced in an article I found in 1888 where somebody actually illustrated the mechanism for constructing tangent lines between two circles. And let me just bore you a moment by showing the process. Okay. Take the radii of the two circles, subtract the radius of circle B from the radius of circle A, construct new circles at the center of A based on the difference between the radii and the sum of the radii. Then construct a circle that passes through both the centers of both circles, but which is centered at the midpoint of the intersection of the line connecting those two centers, and find the intersections between the red dotted line and the blue dotted lines. Then construct lines that go from the center of circle B to each of those 4 points and offset them in the proper direction, and then you've constructed the tangent lines. Okay, I didn't know. I just thought that was utterly cool. Okay, let's turn off the ephemera. Generally speaking, you have 4 tangent lines associated with 2 circles, but sometimes when they meet at a point, then one of the tangent lines disappears. When they overlap, then 2 of the tangent lines disappear. When one is inside the other, then you only have 1 tangent line. And when they're inside completely, then you have 0 tangent lines. So you either have somewhere between 0 and 4 tangent lines associated with 2 circles. Clearly, if you get more circles, then you've got more tangent lines. Okay. And that geometry sort of looks like Paris. Okay, now what can we do with that geometry? Well, how about we flow text and graphics into it? I mean, that's a natural thing to do when you see geometry. Put stuff in it, right? You know, you've got a box. Why not load it up with stuff? So in order to load it up with stuff, it ends up being a little bit tricky. First of all, you have to realize that these lines are SVG lines just drawn with an x1 and an x2 and a y1 and a y2. So we have 2 points that identify the line. And from those 2 points, I extend it out to meet the edge of the screen. But how do we recognize any natural ordering to the segments that populate a line? In other words, the crossings of these things determine a series of intersections, but those intersections have no intrinsic order to them. Nor is it necessarily easy to find the polygons defined by this linear arrangement. And that ended up being kind of complicated. But let's hide the circles for a moment. And there you see the lines and all the intersections between the lines. Each of those intersections is sort of interesting. You can also, if you wish, grab one of these things, and as it moves around, the intersections naturally move with it. Okay, now, in order to find the polygons, let's back out for a moment and see if I can explain a little bit about that. Suppose I'm looking for the purple polygon. First of all, it isn't a polygon. It's merely a place between lines. So how do I computationally discover where the polygon is? Well, the way that we figured out to do it is to start at any arbitrary line and walk along that. Well, walking along it is not necessarily well defined either, because each of the intersections is defined by the lines that happen to coincide at that point. So we first had to place the line segments. The line segments associated with that line can be identified, but then we had to put those in order. Once they're in order, then we can walk along a line. And let's say that we happen to be at the lower, at this point right here. Then we can walk forward until we come to an intersection. Then turn left. What does left mean? Well, left is a concept that has to be intuited from the geometry. So let's walk along that line to the left until we come to another intersection, and then let's turn left. And let's continue turning left until we get back to where we started, and we can recognize where we started because it has an ID. Okay? And that's the process by which a polygon is found. However, as we traverse all the lines here, we're going to find each hexagon 6 different times. Well, actually, there are 6 lines that define it, and we're going to possibly be walking each line 2 different directions. So we could find each polygon as many as 12 different times. And therefore, some bookkeeping has to be done to make sure that we don't find duplicates of the polygons. So that's sort of the process involved in doing all of that. So let's just start with a simple line arrangement. Oh, another thing to say is 2 of the tangent lines cross through the center of the circles, and 2 of the tangent lines are outer tangent lines. We can turn off the outlines or the inlines. And so that gives us a little bit more flexibility in the class of geometries that can be defined by these line arrangements by turning off subsets of the lines. But once the polygons have been located, then we can do things like filling the regions with color. Right now, I'm just choosing random colors that are not too dark. But suppose we also wanted to fill up some of these polygons with an image. Well, SVG has the ability to do that because we've got clip paths. So, boom, I've plopped an image into a polygon. There are a couple of different ways of plopping images into polygons. For example, I can put the entire Tower of London into the bounding rectangle that surrounds that particular polygon. Or I can use what I call global mode, where the shape fills the entire screen, and each polygon becomes a window into that particular image. Okay, so that's sort of fun. We also figured out a way to allow access to local file space so that if you have your own local files, you can simply access them from your drive and plop them into a polygon. Now, what else do we want to do? Well, we might like to be able to place text into one of these things. So London Bridge is falling down, and boom, it flows into the polygon. Now, we've got some problems with this. This is an open source project, by the way, and we welcome help. So the text flow is not working real well. It's hard to flow text into non-rectangular shapes. Well, it's not impossible, it's just difficult. And sometimes when I do this, it's going to screw up, like there. There's a good example of how it didn't work well. There's another example, but that's the general notion. The other thing, of course, is we'd like to be able to save the work from this. And right now, the interface is a little clunky because if I want to save the work, I go to here and say serialize, and kaboom, it's been converted into an SVG document. If you take that SVG document, if you take that text, copy it to the clipboard, paste it into an editor, save the file, and then open it up, sure enough, you've got a web page. Okay? And as an example of the output from this thing, here's this example that we did for this conference. And that's not the right thing. That's a different example. Let's try that. There we go. And you'll notice that as you mouse over these various different things, there are actual links to live websites. Some of this was obviously authored by hand, so the output What the output from Tansy gave us was the skeleton of an SVG page into which we went in and hand put anchor tags and so forth. I also had to move text around a little bit to resize it and so forth. So there's still some hand editing associated with this. It'd be really nice to have something that allowed me to place the graphic, resize it, and move it around a little bit. But you'll notice that you don't have to have things, shouldn't all web layouts have a triangle near the center, because, the triangles help provide stability to an architectural shape. So that's obviously a good point of design right there in terms of keeping things from falling apart. Okay, now let me show you another thing that Tansy does. As I mentioned, I was disappointed that font design was done inside rectangles. And I thought, wouldn't it be cool to have something where you can design a geometry in which a font family can be defined, where the font family shares familial resemblance across all of the individual glyphs based on an underlying geometry, such that as you go in and modify the geometry, the entire font family changes, so that instead of taking 60 hours to create a font family, you might be able to do it in 1 hour. And you can do it for free on the web without having to pay somebody for software. So let me just show you what the idea here is. Let's start with a very simple geometry. I'm going to turn off the circles. I'm going to turn on the line segments. Although that didn't work, did it? Which browser am I using? Let's try that again. Well, it's not working. Isn't that funny? Sometimes the program seems to hang a little bit and needs to be restarted. Let's try this once again. Let's draw some circles and some tangent lines. Let's turn off the circles and turn on the segments. And darn it, they're not working. Ah, there we go. Yeah, they're just skinnier than I'm used to. Okay, so there I chose a particular line segment. Let me choose another line segment, if I can grab the darn thing. There we go. Can anybody identify which letter of the English alphabet I'm trying to draw here? P? Yeah, P or lowercase b, but I'm thinking of an uppercase P right now. So let's save that as a glyph. Darn it, my screen resolution is all screwed up. That's what the problem is. Let me try really quickly to change the screen resolution. Let's bump it up higher and see what happens. Let me start over. Give myself a little bit more real estate. Restart. Okay, let's try drawing a P again. Segments. Hello. This is going to be a backwards P, but that's all right. Now, let's hope my glyph menu comes up. Darn it. Well, it seems like maybe I don't have the right version, but let me demonstrate what should be happening. Okay, so there I've selected a cluster of segments. And when I say save glyph, what should happen is that we get a little list of the alphabet that we're currently working with. In this case, just 26 letters of uppercase English. And having selected a set of line segments, I then click in the rectangle corresponding to the glyph I'm trying to create. The control points associated with that SVG path are then illustrated, and I can turn a selected coordinate into a cubic. Instead of having a linear set of arrangements, I can say I want this one to be a cubic Bezier spline, and then it converts the thing into something that looks like that. Then what's done is something that I call bloat wrapping. Shrink wrapping is something you all know about. Shrink wrapping is where you take a rigid object and a flexible container, and you wrap the rigid object with the flexible container. In this case, we have a rigid container but a flexible interior. And so the appropriate term for that, I guess, would be bloat wrapping, which would be the inverse of shrink wrapping. And what happens next is that the shape then moves to be confined by its bounding rectangle, so that as you rotate the thing around, it squishes to conform at all times to the bounding rectangle of the shape. Therefore, you're able to define a glyph. And if we're lucky, if I'm lucky, there is a font family that I created in about 1 hour of work using this tool. Now, it's not necessarily the perfect font, but you know how much companies pay to have fonts created for themselves? A lot of money, because it takes a long, long time to do it. And here, you can sit down, and boom, you've got a font family. But furthermore, if we're successful, then in the next iteration of the software, we will be able to go back into circle mode, start dragging the lines around, and simultaneously, all of the glyphs will remorph themselves to fit their bounding rectangles, so that you can easily tweak an entire alphabet in one fell swoop. At least that's the hope. The paper that actually describes everything, as well as links and so forth, are here on the web. So textual descriptions of all of this stuff and the rationale behind some of it is provided. There's a fairly lengthy bibliography that sort of got mangled in the process of converting from Microsoft Word to PDF back to HTML with many hands involved. So the bibliography is a little flaky right now. But there are several things we want to do. First of all, making a simple user guide. Making it so that as you change the geometry of the line arrangement, the polygons, the contents of the polygons would reflow, so that the text would reflow, the shapes, the graphics would reflow, and so forth. There's a problem there in the sense that sometimes if you have 3 lines and you move one of them so that it moves to the other side of where the other 2 used to intersect, then a polygon suddenly disappears and another one might emerge. Sometimes polygons disappear. What happens to the contents of those polygons as they somehow move into hyperspace? And I'm not quite sure how to handle that problem. Improved text flow right now, it's just kind of buggy. I encountered a new bug today that I wasn't aware of, and that was that when I'm working with a funny screen layout, or a different size than I was accustomed to, the font editor isn't quite working properly. We'd also be able to like to be able to take an existing font, bring it into here, locate the appropriate tangent lines and let you manipulate the entire font family concurrently on the basis of these control lines. And it would also be nice to be able to take a couple of polygons that join at a line segment and just remove that line segment so that it becomes a larger polygon, so that we're not restricted to strict line arrangements, but something more resembling a Voronoi diagram. Anyhow, that's, I think, all the time I have, but maybe we have some time for questions. Doug.
So there were two things that you mentioned as open issues. One, the text flow. I mean, obviously, SVG and CSS are going to be allowing text flow into arbitrary shapes in the hopefully near future. But I realize why you wouldn't want to count on that. But I'm wondering why you had that effect. Where, I mean, aren't you just breaking down the sections into rectangles and then?
Well, yeah, I'm just essentially running a series of parallel lines until they intersect the sides of the polygon. In order to do it, I had to walk the left and right sides of the polygons to figure out where the left was and where the right was, and then run line segments that went from the left side to the right side. And it should be a trivial problem. We just screwed up the code a little bit.
Oh, okay, okay. But the second thing you had the issue of wanting to save the result, and I found a technique to have a little button that you, or button or link that you click on, and it serializes as base64. It lets you download directly, just like as if you were hitting a save button.
Okay.
So I
wouldn't have to go through the clipboard
exactly.
to do that. Yeah. Yeah, that would be nice. Yes.
With your font making tool, like when someone's designing a normal font, then rounded letters like the O's and stuff extend out the tops of what would normally be the height of, say, an X, because otherwise curved objects look smaller and things like that. So would your float wrapping ever contain features that would allow you to kind of push beyond extents to create something that's more readable?
Yeah, at some point in time, that would clearly be an objective. Right now, they'll all be bloat wrapped to the same size rectangle, and clearly real font families don't have that property. So yeah, by all means, you'd have to build an interface that allows people to do some resizing of the font of the particular glyph once it's been built. But that particular alphabet I showed you was created with only 4 line segments, a geometry of just 4 lines. Clearly, you could get something more realistically by using 6 lines or 8 lines or something like that. So anyhow, tell your local web representatives that we don't need rectangles anymore. We can work with more fluid geometries. Yeah.
I know you mentioned about the introduction of wrapping in CSS. I wonder if you'd seen why Adobe introduced wrapping and text flow.
Right. They had a proposal before one of the working groups on that, and my understanding was it was not adopted.
But there's an issue with, it's called CSS regions.
Yeah.
And there is a difference of opinion among browser implementers as to whether this is a priority. Google has the opinion that it is not necessary, where Apple seems to like it, and Microsoft also seems to like it. Don't remember where Mozilla comes down on that. But yeah, there's a solid proposal. It's workable. It's just a matter of whether the browser
We want text and shakes.
I do too.
Yeah.
I've
Yeah,
wanted it for
I
many,
know.
many years.
Yeah. In fact, wasn't it in SVG 1.2?
Yes, and it was removed because we couldn't get implementations.
Yeah. Yeah, so in one sense, it is a part of the official W3C standard. It's just that people decided not to.
It's not. So, no, we removed it.
Okay.
Because we did not get consensus on whether it should be included.
Okay.
So it has been in specifications. There is specification text.
Gotcha.
We do not have standards
Gotcha.
about it.
Gotcha. Anything else? Well, is it lunchtime?
I hope so.
Let's do that.